So this is the lecture 6 for chemical bonding and molecular structure for class 11. So in this class already I have taught about the Vesper theory and Lewis dot structure. But if you see in the Vesper theory and the Lewis dot structure, what informations we can get, just what is the limitations about this two theory. One is the Lewis dot structure, another is the Vesper theory. So first of all, if you see that the Lewis dot structure, this Lewis dot structure theory, from this Lewis dot structure, just we can get the information about the how to write, how to draw the structure, to explain Lewis dot structures. And also if you know that Vesper theory, this Vesper theory and the Lewis dot structure both has the some limitation. Okay, what limitation? First one is the how to draw the structure, that's we can know, but these two theory fails to explain the formation of chemical bond, how the chemical bond is forming. Okay, we know that it is a covalent bond. Suppose X and X, it is a covalent bond. Hydrogen molecule, there is a covalent bond. Okay, HCl, there also the covalent bond, but it is a ionic covalent bond. Okay, so this bond is the forming, but how this bond is the forming, how the covalent bond is the forming, how the ionic bond is forming, that actually cannot be explained by this Lewis dot structure and the Vesper theory. And also if you see another thing, this two theory actually does not give any information, of difference in bond dissociations, energy, bond dissociation energy, and the bond length. Okay, so these two theory didn't give any information about the bond length and the bond dissociation energy. What is the link between this bond dissociation energy and the bond length? So these are the failure, these are the limitation of the two theory. One is the Lewis dot and the Vesper theory. But so to overcome this type of the limitations, we are going to that another theory. One is the VVT theory, valence bond theory. Okay, so this valence bond theory, 1927, Hitler and London was introduced, and it was developed by the Pauling. So 1927, at the 1927, okay, Hitler and the London, they have introduced this theory, but further by Pauling it was developed. So about a molecule, how many covalent bond is there, how many ionic bond is there, and what is the structure, and how we can draw the structure. These are the basic thing, and we can know from the Vesper theory and the Lewis dot structure. But there is no information about the bonding, how this covalent bond is forming, how this orbital theory is coming, how these two orbitals are involved in the bonding theory. Okay, so to explain atomic orbital and electronic configuration. To explain this atomic orbital and electronic configuration, the valence bond theory, this is the VBT, was the introduced. How this atomic orbital and electronic configurations are the involved, and how this atomic orbital theory and the electronic configuration has been introduced in this valence bond theory, that we will know today. So let us consider is the H2 molecule. So this is the H2 molecule. This is the H2 molecule. There is the atom. This is the hydrogen atom, and this is another hydrogen atom. Now I am considering these two hydrogens atom is a HA and the HB. Okay, so this is the HA hydrogen atom, and this is the HB hydrogen atom. Okay, so each hydrogen atom has the electron EA. HB has also the EB. Similarly, it has also the nucleus N of A. It has also the nucleus NB. Okay, so this is the two atom HA and the HB. They are the covalently bonded and they are forming H2 molecule. But here both atoms are the same. But to introduce the some interaction and the repulsion, we are considering here this is the HA and this is the HB. So HA atoms has the electron EA and it has the nucleus N of A. Similarly for the HB hydrogen atoms. Now whence they are HA atoms, so suppose this is the Na HA atoms. Na, it is the nucleus, it is a positively charged, and it is the electrons. So this is the electrons, it is a negatively charged. So it is a positively charged and it is a negatively charged. Similarly here also HB atom is present. So it has the nucleus HB, it is a positively charged, and it has the electron, this is a negatively charged. So what type of the interaction is present between these HA atoms and the HB atoms? Okay, so first of all, there is present two type of the interaction. One is the attractive, another is the repulsive, or we can say attraction, another we can say this is the repulsion. Now attraction, always if you see, attraction is present between the positive and negatively charged, and repulsion is present positively and the negatively, positive and the negative charge. So this is for attraction and this is for repulsion. Okay, so if you see, these are the two different atoms HA and HB. So there is the attraction is present. So this is the between the own nucleus and the electron. This is the attraction is present. So attraction is present. But attractive force is present. N of A electrons. This is one attraction. Another attraction is also present. NB and that one. So this is the attraction. Another attraction, this nucleus and these electrons. So N of A electrons B, and another attraction is present, NB and electrons A. So this four type of the attractive force is present between these two hydrogen atom. One is the H of A, another is the H of B. So two hydrogen atoms are the present in the H2 molecule but between these two hydrogen atoms there are the attractive force and the repulsive force. But attractive force, there is the four type of the attractive force. And the first one is the n of a electrons n of a. That means that inside the H of a atoms this attraction is present. Inside this Hb this attraction is present. Then another attraction is n of a nucleus and electrons b. Another attraction n of b plus and the electron a. So these are the attraction. Similarly is repulsion. So repulsion, if you see, positive positive, negative negative. So repulsion is present only the two type. This is the repulsion. So n of a, this is also positively charged. N of b, this is also positively charged. So that's why between these two nucleus there is present the repulsion. Another repulsion is present these two electrons. Okay, so another repulsion is electrons a and the electrons b. Okay, so between these two type of the electrons, but electrons are the negatively charged. So when is these two negatively charged as the coming to towards itself, then there is the repulsion. Similarly for the nucleus case, because the nucleus is the positively charged, that's why these are the repulsive force. So in a hydrogen atom there is repulsion and the attraction. The four attractive force is present and the two repulsive force are the present. But to overcome, this is the thing. So experimentally it has been proved that the attractive force is the more than the new repulsive force. So if you see, there is the four attractive forces present. There is the two repulsive forces present. So it has been proved experimentally that attractive force is greater than repulsive force. Okay, so attractive force is greater than the repulsive force. Okay, that's why what is happening between this Hj and the Hb atoms, they are forming a bond. Suppose there is the repulsive force is the higher, then there will be no bond between this Hj and the Hb. So it has been proved that attractive force is greater than the repulsive force. That's why they come to a stage where the need force of the attraction balance the force of the repulsion. So at stage where the need attraction force is equal to need repulsion force. So this force has the balance at a stage. So in that stage, two hydrogen atoms are the said to be bonded together and to form a stable molecule having the bond length is 74 ppm. So at that stage, the attractive force is equal to the repulsive force. So in that stage, two hydrogen atom H of A and the H of B, these two hydrogen atoms are bonded to each other and form H2 molecule with hydrogen bond length, where this hydrogen bond length is 74 ppm. Okay, so that is the thing. So if you consider here, I am considering a small molecule. This is the H2 is a molecule. So there is the two atom is present. One is the H of A, another is the H of B. So two hydrogen atoms has a nucleus N of A, electrons E of A. Another thing is that Hb also has the Nb and the electron B. So when these two hydrogen coming to each other, then they are for then there are the several attractive force and the several the repulsive force. Okay, so what is the attractive force and what is the repulsive force? So when this positive negative charge is there, then there is the attraction, and positive positive and negative negative, there is the repulsion. So these are the attraction, these are the repulsion. So experimentally it has been proved that there is the four attractive force. That's why the attractions will be the greater than the repulsion. But after that they coming to a stage where this neat attraction force is equal to the repulsion force. So at this stage they are forming hydrogen hydrogen bond. This is a covalent bond, hydrogen hydrogen covalent bond, and they are forming H2 molecule. So when they are forming this H2 molecule at this stage, they are forming a bond. This is the bond length. This bond length is 44 ppm. Okay, so this is the thing. So in this way, you have to consider the repulsive force and the attractive force. So there is a bond, hydrogen hydrogen is bond. So bond length is 74 ppm. Now, what is the bond enthalpy? Or we can say, what is the bond dissociation energy? So bond enthalpy means to break whatever energy get released when this bond is formed between the two hydrogen atoms is called the bond enthalpy. So this energy also is required for the bond dissociation energy. What is thing? So when these hydrogen atoms and another hydrogen atoms coming to each other and they are the forming a hydrogen hydrogen bond, then some energy is released. Okay, so this release energy is called bond enthalpy. So this release energy is called the bond enthalpy. So for that for the hydrogen atom H2, or this hydrogen molecules, okay, the bond enthalpy equal to 435.8 kilojoule. So that means that when hydrogen hydrogen bond is forming, when hydrogen hydrogen bond is forming, 435.8 kilojoule per mole, this energy is released. Okay, so that is called the bond enthalpy. So to make the bond we need this amount of the energy. Similarly, to break this bond, this amount of this 435.8 this kilojoule energy is required. So this energy is called bond dissociation energy. Okay, so bond enthalpy means when a bond is forming, how much energy is released, that is called the bond enthalpy. Similarly, so to break this bond, whatever energy is releasing, that means this amount of the energy is required to make a bond. So this amount of the energy also required to break a bond. Okay, so actually So bond enthalpy, that means a make a bond, and bond dissociation energy is a break a bond. Okay, so that is the thing. So this is the thing. So one is the make a bond, another is the break a bond. Okay, so for that case, hydrogen atoms, we need the energy bond enthalpy is 435.8 kilojoule per mole. So here is a curve. If you see that for that hydrogen atom, how this actually forming. So what is happening here? Here the two hydrogen atoms are the bonded. In that situation, two hydrogen atoms are the bonded. Okay, so here the H and H, actually H and H situation. So here the bond length is 74 pm. Okay, here is the bond length is 74 pm. But when, if you see the nuclear distance is coming, that means they are going to like that. Okay, so two hydrogen atom is the bond distance is large. Okay, so bond distance is large, that means the energy also will be large. So this is the dissociation energy, but or we can say the energy, dissociation energy. Okay, so energy, so this is the kilojoule per mole. Okay, and this is the nuclear distance is increasing here. So this is the nuclear distance. Okay, it is pm unit. So in that situation, what is happening, this distance between these two hydrogen atoms is increased, but in here, if you see, this hydrogens bond is not here, it's a broken. Okay, so hydrogen bond is broken. So in that energy, hydrogen bond is broken. So that energy is 435.8 kilojoule per mole. So this is the curve. In that way, any hydrogen bond, any atom bond has been dissociated. Okay, so this is the curve is there. So that is the fact. So this so hydrogen atoms. So with these hydrogen atoms, here we have discussed about that bond enthalpy and the bond dissociation energy, and how this bond is forming and how it is dissociated. Now after that, we will about know the orbital overlap concept. So what is that? We know that, first of all, we have to know the orbitals. Okay, we know that s orbitals, p orbitals, d orbitals, f orbitals. S orbitals is spherical, it is size is like that. P orbitals is dumbbell akriti, so it is a dumbbell shape, and d orbitals has the 3d orbitals. It is we can say it is like that actually, this type of the orbitals, and f orbitals also is different thing. So these are the we can say dumbbell shape. The shape is the dumbbell, but only the s orbital is the spherical shape. Okay, so overlap, this term is coming. So orbitals overlap. So s and p, suppose s and p, two orbitals can be overlap. Okay, so before going to this overlap, you have to know first of all that s orbital. What is happening here? The s orbital is the spherical. This is the s orbital. Okay, s orbital is the spherical. It is the nucleus is present at that position, and this is the orbital. This is the spherical shape, and then this is the p orbitals. First of all, we will know about these two orbitals. This is the s orbital and p orbitals. The p orbitals, this point is called node. This is the positively charged, this is the negatively charged. For the p orbitals, always there will be two lobes, one is the positively, another is the negatively charged. Okay, and the center is the core, that node. Note that means that here the electrons density equal to 0, but in that to here electron density not equal to 0. Okay, so this is the two orbital, one is the s orbital, another is the p orbitals. Okay, so now that what is the overlap? So overlap means this is the s and this is the p. So this type of the overlap would be happened. So this overlap is called sp overlap. Okay, sp, two orbitals are the overlap. So when these are the overlap, that means that they are forming a bond. That means that the overlap of two orbital, one is the s, another is the p. It means that sharing of electrons forming a bond. Okay, so what is happening? So this is the s orbital. Suppose this is the hydrogens. So hydrogens has a one s orbital. So hydrogens has a one electrons, and p orbital also has a one electrons. So these two orbitals are the mismatch, and they are forming sp overlap, and they are forming a bond. Okay, so there is a some point is that when the greater overlap, the stronger bond is formed. When this overlap is greater, when this stronger overlap, when this greater overlap, that means they are forming stronger bond. When it is a weak overlap, they are forming weak bond. Okay, so actually the formation of a covalent bond between the two atoms resulted by the pairing of electron present in the valence shell having the opposite spin. Okay, so what is mean that line? So this is the one electron. So this has the spin s equal to plus half. Another electron has a spin equal to s equal to minus half. So when the covalent bond is forming, when these two opposite spins electrons are pairing. So when that electrons are the pairing, then the covalent bond is formed. So these are the thing is present here. Now I am going to the overlap of how many types of overlap is possible, and what is the positive overlap and what is the negative overlap. So the s orbitals always the positively charged, and p orbitals has a positive note, positive and negative, and this one is the note. So first I am going to the positive overlap, positive or in phase overlap. Positive and the phase overlap, that means that two phase is present. The positive phase or the negative phase. Okay, so positive phase or the negative phase. So the two phase are the same. Two phase are the same. That is the phase overlap actually. That is called the phase overlap. So how it is forming, what it is possible. So first of all I am going to that pp though two p orbitals, so pz and pz. So positive of phase overlap, how it is forming. So this is one pz orbital is a positively charged, negative charged. This is the one pz orbital, another pz orbital is also is there. So this is a positively, this is the negative. So this is a positively charged, so this is a positively phase overlap. Okay, so two phases are the same, so this overlap is forming. But if you see this is also the positively phase, this is also the positively phase of the another pz orbital. Whence the two positively charged phase of the two different pz orbitals are the overlap, that is called positive overlap. Second thing is that PZ and S, positive, negative. So this is the PZ and this is the S. So this is a positive. So this overlap is forming here. So if you see this overlap is forming between these two lobes, this one also is positively charged, this one also is positively charged. So that is the phase overlap. Another is that PX. How it is that? Positive, negative, positive, negative. So this is the one overlap. This is also the one overlap. If you see, that overlap also is forming the positive phase. That overlap also is positive the negative phase. So their overlap between these two phases is the same. Here also the overlap between the two phases is the same. That's why it is a phase overlap or the positive overlap. Another overlap is the negative or out of phase overlap. Negative or out of phase overlap, that means that two phases will be different. The positive, negative, negative, positive. So this overlap is happening, but if you see, this phase is positive, this phase is negative. That's why it is out of phase overlap. S orbital always is positive. So this overlap also is formed, but here what is happening? It is negative, it is a positive. That's why it is a out of phase overlap. So this here also is overlap is formed. Here also is overlap is formed, but it is a positive and this is negative. This is the negative. This is the positive. So this phase two, these two phases are the different. That's why these are the out of phase overlap. PY, how it is that? Here also the overlap is forming, but it also the two phases are the different. Two phases are the different. That's why. Okay, so these are the negative phase overlap and these are the out of phase overlap. Now I am going to that zero overlap, or you can say this is a out of phase overlap due to different orientation, direction of approach. So zero overlap, that means that what is happening here, positive, negative, and this s orbital is coming. So there is no overlap actually. Zero overlap, that means there is no overlap actually. This is not a overlap. Okay, these are the zero overlap. So these are the zero overlap. Okay, so there is a no overlap. Another thing is that here I am drawing as a p orbitals. P orbitals is the three. One is the px, another is the py, another pz. So three orbitals is present: px, py, and pz. How it is actually drawing? That is the fundamental thing. We know that three coordinate. It is actually x, that is y, and that is z. Minus x, minus y, and minus z. Okay, so when we are drawing that pz orbitals, so it will be that like along that pz orbitals. Okay, so it is a pz orbital. So it is a pz orbitals. Now the px orbitals. So px orbitals is horizontal. So it will be px orbitals. So it is a px orbitals. Another is a py orbital. So another is that py orbital. So this is a py orbital. So this is why the py orbital. So this is the pz orbitals, this is the px orbitals, this is the py orbitals. So these three orbitals actually present in that way. So p orbitals are the three, and there is the px, the py, and the pz. S orbital is the spherical, it is always positively charges. And another thing, there is the three type of overlap. One is the positively, this is the negatively, and the zero overlap. Here I will stop today's class, and in the next class I will start about the what is the sigma bond, what is the pi bond, SS overlap, what is that, and the hybridization. So here I am going to stop the today class. Thank you very much.